Hello again. Today I want to give you yet another example of how computer science is relevant to my research. Virtual visuals where students manipulate visuals using a computer, like the ones that I showed you in my recent video on human-computer interaction, these virtual visuals are actually a relatively recent development in education. Traditionally, instruction in many fields uses physical models. So these don't even need to be fancy. We often use everyday items like beakers to illustrate fractions or buttons to show counting, or actually you can also use buttons to show electrons. One advantage that virtual visuals have over these physical models is that students can get immediate feedback and hints while they're working with the virtual visuals. But there's actually no reason why we shouldn't be able to integrate physical models into educational technologies and then give students feedback on their physical models too. All we need is image recognition that can diagnose whether students built a correct model, and if not, what it is that they got wrong. So two of my students, Sonu and Ushmal, are helping me with this part of my research. We're starting this on a rather simple physical model of atoms, a shell model that shows an atom with a nucleus in the middle and shells around it, and then electrons residing in the shells. And to assess if a student built a correct shell model, we need to know how many electrons the student placed in each shell. So Sonu and Ushmal are training an algorithm to recognize images, and to do that we need data on what possible correct and incorrect shell models would look like. So we collected a lot of images, and those are essentially the data that we feed our algorithm. We're still working on this, but the plan is that once we have trained the algorithm, we can integrate it into CamTutor and use that to give students feedback on their physical shell models. So that allows us to integrate physical models into educational technologies that can give adaptive feedback and guidance for students to build models.